Business Center Power Hour. And due to such a large turnout, we have all attendees in listen-only mode, but we welcome all questions and comments, so feel free to type them in into the Q&A tab at the bottom of your screen, and we'll respond accordingly. Today, we'll be discussing one of TBC's latest tool sets that will be available in version 5.20, creating vertical designs. As the world around us continues to boom with technological advancements, it is only natural to implement those technologies into our construction job sites. Newer and faster ways in creating and managing data, all while staying on track with site plan requirements, are becoming the new normal. Accurate 3D models are a necessity on today's high-tech job sites, one important reason why developers built TBC's Create Vertical Design. And without further ado, I'd like to introduce Nick Viferick and Alan Sharp, who will be hosting today's Trimble Business Center Power Hour and going over what the Create Vertical Design tool is, what the workflow looks like, and finally, how the data is to be prepared for it. But before we dive into the technical aspects, I would like to pose a question for our hosts to get things started. We know TBC is a powerful tool used to create accurate and integrated models, but what spurred the creation of this tool and what is it?
Okay, well, good morning, everybody. It's Alan Sharp here. So yeah, Dylan, that's a good question. We several years ago, we introduced a functionality set in Business Center for designing intersections. So the ability to design T-intersections, roundabouts, crossings with islands and turning lanes, and also ramps and interchanges for major highways. And that was designed based on some technology that Trimble acquired from a Norwegian company where we have a dedicated highway engineer working on that team. And the general reaction we got from a lot of people around that tool was it's a fantastic tool, and if we were given the ability to truly design intersections on road projects, then that would be awesome. And a lot of people have used it for that, and they have used it for like re-engineering projects where maybe slopes didn't work quite right, or where they had some freedom to make some design options. However, the commonest feedback we got from everybody was, really what we need, though, from a data prep standpoint or a data modeling standpoint, is the reverse. We start with a two-dimensional layout drawing from the engineer, and they give us some information about elevation controls. They give us some information about slopes between elements. And really what we need is a tool that can invert the process of design and reverse engineer a set of plans into a 3D model in a more automated way. And we want it to be more parametric. In other words, one of the biggest challenges with data prep is in the way it's done today anyway, is that you add elevations to things, you put almost like what we call static controls onto things to bring them up to the elevation or the location that the engineer specified. And the challenge with that is if something doesn't work quite right, in other words, you get drainage problems, or you've got something that needs to be redesigned, or you need to interpret a gap that was left in the design, then you need to start kind of inputting extra information and manipulating the information you've already entered to make it work. And the problem with that is it's not parametric. So as if you make a change in one place, you've then got to make that same change in every other place where that instance it affects the model. And so we wanted to kind of come up with something which was a reverse engineering tool to be able to build vertical models from basically two-dimensional line work, whether you bring that data in from CAD or whether you bring it in from PDF at an estimating stage, and provide a set of parametric tools that allow you to A, build the model from scratch, but then B, manipulate the model by being able to make changes on the fly. So if you, for instance, want to change a slope of 2% to 3% on a cross slope of a road, or from 2 to 2.5%, then it's not just the edge of pavement that changes, but all the other elements that are associated with that. So you have the 4% to the flow line, you have the 1/2 foot to the top of curb, the 1/2 foot back to the back of curb, the 2% to the sidewalk. All those things are parametric related to the first thing. So when you make one change, it ripples through the model and affects all the other things that are associated with that. So the same engineer that built, or the same engineering team that built the intersection design model, we took the engineering model, the actual computation model from that, and put it underneath a new set of tools that allows you now to define parametric entries, very much the same way as you do for road models, but this now for site models. So you can input, for instance, the cross slopes between things, the elevation differences between things. You can put in free slopes at a direction, or tilts to put things onto a tilted plane in a parking lot for things like islands. And the system will grow a three-dimensional model that's parametric and sequential. So if you want to make a change somewhere, you can make a change and it will ripple down through the rest of the model to build a 3D model. So what we're going to show today is really the basics of how that works, the building block elements that make this model so powerful. We'll show you some simple examples to kind of get you warmed up, and then we'll dive into some more complex issues like a complete intersection model, and then also a complete road network for a subdivision to show you how the tool can be used in relatively complex scenarios to build very accurate 3D models and to fix the issues the engineer either didn't design, typically around junctions, intersections. They may model the highway to the intersection and across the intersection, but the bit that joins the two together, they leave it to the contractor to work it out. They often design elements and they miss things out or they get it wrong. So there's drainage problems on a site. Well, this tool allows you to not just remodel that, but also do what if scenarios. You can sit with an engineer and manipulate the design to show the engineer the problem and maybe some potential solutions for it in a virtual way. And then you can leave that information with the engineer and they can do the redesign for you if necessary. So this tool is extremely powerful for both reverse engineering plans to make 3D models, for doing temporary works design, but also for doing value engineering and engineering integration work where you're trying to solve technical problems on site based on problems with the design. So we'll go through the whole process here. Does that answer your question?
Yes, thank you, Alan.
Okay, so Nick may jump in at the end here. Nick, feel free to dive in any time you feel like you want to make a comment. I know you've been working with quite a lot of people since the initial training we did at PUG a few weeks ago. But what I'm going to do is I'm going to start by just going through some of the training materials that we put together for the Power User Group a couple of weeks ago. And I'm going to bring in a set of what I call simple examples to show you how the building blocks of this vertical design tool work. Now, these are really simple canned examples, but I'm building it up from, how can this tool help me with a simple line, like an alignment, for instance? How can it help me with simple pairs of lines? How can it help me with multiple lines? How can it help me with things like, irregular patterns like a circle and a square like you would find on a tank farm, for instance, moving on to things like an intersection model, then moving on to things like a parking lot. These are all canned examples to show how the tool basically works. And then I'm going to dive into some real world model examples to show you how it can be used in practice. So start off with the vertical design tool. It's a fairly simple tool on the face of it. We basically would go to the create vertical design command. And in here, you pick the lines or the alignments that make up that vertical design. The tool will use CAD lines, polylines, line strings, and alignments. It doesn't matter. It uses them in any combination. There are times when using line strings in preference to alignments is helpful because you can break line strings, you can't break alignments, and there are certain conditions where we're still improving the tool further into the future where you get loop alignments, and in that case you really want to convert them back to line strings and then use the line strings in the model. But we'll show you with these tools, and then I'll show you some examples where we have alignments in there too. So when you build a vertical design, you can build a vertical design, and as a minimum, you need a line. That line can be two-dimensional or three-dimensional. So I'm just going to call it one line. And I'll talk a little bit about the difference between 2D lines and 3D lines. So if we bring in this 2D line into a vertical design, it's treated as a 2D line. If I add a 3D line to a vertical design, initially it will be locked in the 3D design. In other words, it says it's already elevated. It's already got elevation control, so we're not going to let you change it. If you decide to unlock it, that basically makes it free float. It stays as it was until you make some command to it that changes its elevation. Then it becomes a 2D line and gets elevated by the vertical design tool. So depending on how you use it, you can start off with either 2D or 3D lines here. So I'm going to use this as a one-line design. And so let's open up a profile view of this line. Actually, let's add an elevation first. So in the vertical design tool, you can see it's at the top here, it tells me I'm working on the vertical design called one line. You have a rebuild button here, just like you do for surface models. If you want to rebuild it at any time, you can set it to build by user and hit the rebuild button when you want to rebuild it. When you get lots and lots of commands, when you get up to 40, 50 instructions in a command set, having the rebuild by user is a good thing to do because it will save you a lot of time. Selecting members allows you to see the members that were added into this vertical design. So it's just like checking to see which lines are in the vertical design. And then underneath here, you have the main guts of the command. So you have the rules pane where we can define the rules, and then we see the rules list down here. We have a lines pane which shows all the lines that are added. In this case, you can see this design line has been added, but it's locked right. It's not locked right now, so it's unchecked because it was a 2D line. If it was 3D, it would have been locked as I came in here, and then you would have other lines that were 2D that would elevate off this source line, for example. The surface settings is basically when you're building this, you can either build a surface automatically or you can just build elevated line work. So if you hit the create surface button here, then it will basically build a surface as it goes. If you don't do that, then it will just elevate the line work. And there are some advantages to doing either way, depending on what it is you're trying to achieve. And then beneath this is all your kind of controls for the surface. So you can contour the surface, change the edge length of the triangles. You can show slope arrows so you can see what drainage is doing. So anything you want to do with surfaces is in this tab, but this is all dynamically controlled by this command. You can also get at the surfaces in a normal way through the Project Explorer, through the View Filter Manager. Other settings here is the other controls that allow you to, for instance, show the vertical design rules or not show them, use grips on them if you want to. You know, these are things like just settings of how to control things in the process. So we're going to start with the Rules tab. And when we go into the rules, you can see there's a number of different types of rules, like an elevation rule, which has an elevation to a location on a line, a cross slope rule that basically adds a cross slope between two lines, across DZ, which is a difference in elevation between two lines. And then we have a thing called free slope and free DZ, which is very similar to these two, but the difference between these two is this only applies one calculated location on the target line, and it then holds the elevation of that point all the way around the target line. And you'll see that when we get into some examples later on. And the free DZ does the same thing. These can also be at an angle between the two lines, whereas these are perpendicular to the target source and target lines. And then down here, you have a break line to control the model. You have what we call transitions that allow you to control where slope changes will happen along a line. You have connectors that allow you to transfer elevations from one line to another line, for instance, at a T-intersection or a roundabout or whatever. A tilt control that allows you to put a slope and then drop things onto that slope. And then a vertical PI or a vertical point of intersection for putting vertical curves. And that can be a parabola or a vertical arc, depending on the settings of the vertical design. So let's start off with a simple one. We'll put an elevation on a line. So there are certain controls that can be applied to just a single line. Elevation being one, the vertical PI being another, and the grade being a third. So elevation is a point elevation. The grade is a slope between two locations along the line, and a vertical PI puts a vertical curve at a location with an elevation control and a length or a radius, depending on whether it's a parabola or an arc. So when we go into elevation here, if I click on this line and say elevation is 100, let's say, and we say the elevation is right here, that basically just added elevation of 100 to that line. So if we now just highlight this line and go to the profile viewer, and let's just drag the profile view over here, and let's split that vertically or horizontally here, so we can see what happens when I apply another elevation rule. So right now you can see that this line was just elevated by 100 or 400 based on this point that I added in the position here. If I change the elevation and add 110 now, and say that that coordinate is right here, sorry, I didn't catch it. Let's just drag it back on the line now. By changing the position of it there, you can see that now this line in profile has an elevation of 100 right here, and it has an elevation of 110 right here. Let me just do this one more time. I added two instructions there for some reason. Let's delete that one.
Yeah, and the instructions, just as a heads up, guys, too, if there is an error within the instructions that messes something up, it will tell you right away that something's not right. So there's no question as to if you've done something right or wrong.
So the system has a search. What I did there, if I move this off, basically it's saying it can't find a source line. So if you click in free space, I just need to make sure I have my snaps turned on as I want it. So I've got near point turned on here. So I snapped accidentally in open space, and it's saying it can't find a source line. Well, the reason it can't find a source line is that there's a setting for vertical design rules. I just go to that first of all. I just come up here to this here, you can see it has a search distance and what we call a hit length. The search distance is a radius around this point at which it's going to try to find a line. And if it finds a point, now this is 100 feet here, so if I've only got a distance of 6 feet, it won't find a target line or a source line here. If I drag this down, if I click on this instruction and drag it down closer, it will snap to the line and use that search distance to snap itself to a line. And as soon as it can do that, it then applies that in the vertical here. Now, these are vertical controls. They're controlled in the same way as other objects in Business Center. So you can click on any vertical rule and you can move it. And as you move it, it will change the slope directly and dynamically on the screen here. So this is the starting point of being able to see the sort of dynamic nature of the vertical design. If I don't like the elevations I've keyed in, if I need to come back in here and say, let's make that 12.5 because I want to try see what happens. As soon as I type that in, then it will affect the lines that are affected by that. And right now, I've only got one line that's being affected, so you're seeing those changes being applied dynamically. You say, okay, well, that's great. So this means you can just go into any line. If you're given elevations, you can have elevations control along that line, and it's linearly interpolating between the elevation controls. Now you can see there's a slight difference between the way this works and the line string command. And then when I added an elevation of 100, it basically fixes the line before that point to elevation 100. When I add an elevation of 112.5 here, it fixes the line beyond that at 112.5, whereas the line string command would project this at a continuous slope in both directions. So that gives you an example of just something very basic of how you can use a very simple control. Let's just delete one of these controls here. And let's then add a grade rule. And let's do the grade rule here. Let's say we've got a 10% long slope starting from down here somewhere and ending up here somewhere. And so you can see now what it's done is it's held at this location where I defined the 100, it's still fixed at 100, but now it's put a 10% long slope along this line between here and here. So in this direction, downstream, it's going negative, and in this direction, it's going positive to calculate what happens with that slope. And again, the same way with this vertical rule, you can drag this node and move it, and by moving this, you're dynamically updating the slopes and the direction of this line. And you can do that dynamically when you've got many, many instructions. You can do this, and it would affect all subsequent lines that are coming off this one. Okay, let's just take that one off, and let's take the elevation control off as well for a second. Now what I'm going to do is just do PIs, so vertical PIs. If I want to go in and put in an elevation of, let's say, 110 and a parabola length of, let's say, let's go 100. And let's put that point right somewhere here. Now, a single PI doesn't do anything. You need at least two to be able to do this. So let's say we do another one at 123.5. And we're going to make it still 100 length, and we're going to put this one down here somewhere. As soon as I have either two elevation controls and a single PA, or I have two PAs, then I can compute the curve linear alignment. So this is like designing a vertical alignment along the line. Again, with this, you can pick these up and move them. So same way as I've done before, you just click on the vertical rule. Then you can slide that vertical rule back, and by doing that, it moves those vertical PIs backwards and forwards along the line. So again, if you're trying to design an intersection, or you're trying to make an intersection work, sometimes you can manipulate the length of the vertical curve, or the position of the vertical curve, or the elevation of the vertical curve, and let it adjust to make it fit. And you can see how dynamic this is working on just a single line. And then when you start looking at what happens when I work with multiple lines, you'll start to see some of the power of this tool. So that's line-based controls. So elevation control, vertical PI control, and grade control are three line-based controls where they apply to a single line object. Let's move across a little bit here to the second example here. Let's just close this example. And what I'm going to do here is I'm going to open up the 3D view here in the same way, because this one looks better in 3D mode. So in the 3D view here now, if I go to look at this example here, let's take the two-line example so we can see what's happening. Okay, so if I now start off, I've got two lines, and let's say I've got the first line, I have an elevation control and I have a long slope, and then off that I want to do a 2% cross slope or a 5% cross slope or a 2-to-1 cross slope or something between the lines. First rule I'm going to put in here is an elevation rule. Let's put it in at 100. And let's say that elevation belongs somewhere here. And again, I missed it. So let's just move that off a little bit here. Oh, stupid. Start a new vertical design. Let's do that first. And we're going to call it these two lines. And we're going to give it a name, two lines. And apply. The reason I gave this message is because these two lines didn't belong to the vertical design that I've created. Let's move this vertical design up here. Let's put this up here a second. Get that on my screen. Okay, so in here, I'm just going to drag this 100 elevation point back to this line. And what I have to do, let's just delete it and start it again. Oh, I didn't add it. Okay, so let's start a new rule. Let's say an elevation rule. Let's say it's elevation 100. And let's say its start coordinate is right here. So that just elevated that line to elevation 100. You can see these two lines are now separated in vertical space here. If I now do a long slope, and let's say do a grade, and let's do a 5% grade, and I'm going to start it, let's say at the end of the line here, and I want to finish it over here. So now that line has a slope along it as well. And then let's say I want to do a cross slope of, let's say, 10%. And I want to start it from somewhere here to here. What that just did there was it now elevated a 10% cross slope from that sloping line at 5% that has an elevation at 100. So if any of those three values change now, this model would effectively update in real time. So I now grab this grade rule, and let's grab the grade rule, and let's move this slope back a little bit. You can see by doing that instantly it updated the model, and I can do that with the other end as well. And you can see that you can instantly change what's happening with the model. If I go into this rule right here, I can change that one to, let's say, let's change it to 1 and 1, and that puts a 1 and 1 cross slope on there. I change this back to 5%. It's updating the model dynamically as I make any adjustment to any of those three values. Now, the sequence that I do these in is also important. And so if I go back, for example, and just delete these instructions again, just to kind of start from scratch, if I get the sequence wrong, so for instance, I go in here and say, let's do a grade here at 10%, starting at this end over here, and ending over here, it's going to give me a red flag because it doesn't have an elevation to work off. So you can't have a grade rule on a 2D line without having some sort of elevation control. So then if I go in here and say, well, let's add an elevation control and put in 100 and say that elevation control belongs there, it's giving me another error message now because the target line wasn't computed. The reason why is because there's already a grade rule ahead of it. But if I go in here and just drag this rule up one, now it can elevate it and slope it because I now have elevation first and grade second. So be very aware when you're using this tool that the sequence of things that you put in is very important, because if you come back later on and add another rule later in the sequence that makes a change to something that you thought you'd locked down, it will make a chain reaction after that point. So be aware that sequence is just as important as the rules themselves. When you're building this, you have to have them in the right order. So you have to really think through which comes first, which comes second, which comes third. And you'll see that as I start getting to intersections in just a minute. So this is kind of giving you a starting point of an example of this is using a grade. If I use the cross DZ, for example, I can say I want an elevation difference of 2 feet starting between here and here. And so this second line is 2 feet higher than this first line all the way along the line. So it's no longer using a cross slope as a control, it's using elevation difference as a control. So I go in here and change that to 3 feet, then it increases the elevation. If I change it to -1, you can see the effect of sequence there. I just caught one and moved it by mistake. I go in here and say, let's say it's -2 feet. and let's go in the opposite direction. So again, dynamically, I can go in, put in new values, move the location of these things using the grips, and update the model pretty dynamically as we go. Okay, so that's cross DZ. The free slope and free DZ are a little different. Let's just delete that. Let's take a look at free slope. If I do a free slope, and let's say it's a 5% free slope, and I start, let's say here, now I can go directly across, but I can also go at an angle. So if I go at an angle, what it's doing is it's calculating an elevation to this point from this point at 5% slope along this line. And it elevates this point, and then the rest of this line is held at the elevation computed here. So free slope is quite different to cross slope. It's holding the elevation here, and so now you can see that the target line has a fixed elevation of that 5% free slope over there. Now you can have as many free slopes as you want along a line. So for instance, I said I want a 5% slope starting from here going to here. Now I've got two free slopes, and of course that's elevating here and here to calculate it, and it's giving you this twisted surface effect as a result. So free slope and free DZ are both working in the same way. Free DZ elevates this point based on a difference in elevation between here and here along that target line, and that just elevates one point along the target line. Now, when you have elevations like that defined, obviously there's a transition between here and here, which is calculated linear, but that's where you could go in and apply a transition between those 2 points that are calculated for it to say, don't transition directly from here to here, but start the transition here to here. So then this elevation would be held to here, this one would be held to here, and then it would transition between the two. And we'll look at that when we do the three element lines in just a second. Okay, so that's working simple ways with 2 lines. 3 lines is kind of the same but with a little bit more of a twist. So let's start a new vertical design, and let's call it 3 lines. Let's pick these 3 lines right here and call it 3 lines. And apply. And so this could be an example where you've got a drainage ditch, for example, where you know, for example, let's just reorganize my layout a minute. Okay, so in the 3 lines function here, I'm going to say let's start off with a ditch along the bottom here. So we know, for instance, there's an elevation maybe at the end of this line. Let's say it's elevation 100, and we say it's right here. And then we say it's got a slope. Let's do a grade along this line of, let's say, 2%. And it starts right here and ends over here. And now we've got that. Let's just move this along here a bit. So we've elevated this. And then let's say we now know that the drainage swale, either side of that, let's say has a cross slope, and it's a 3-to-1 positive slope. And it starts from, let's say, here to here, and also from here to here. And so now what that did was just built me a 3-to-1, exaggerate that a little bit. It's built me a 3-to-1 slope either side of the drainage swale base here. And you can see the contours are getting formed automatically as I go. So again, nice tools for being able to build out just simple elements. Now, some people look at this and go, "Oh, this is a fantastic tool. You can do, complete subdivision in one set of instructions." You could. But my recommendation is don't do that. My recommendation is to build it up as several vertical designs, and then merge those vertical designs into a common surface at the end. These surfaces can be combined just like any other surfaces. The lines that you create from these vertical designs are also available, and it can be incorporated in any other models. So you can incorporate the lines, you can incorporate the vertical designs in a composite surface, and use this in pieces to model out the areas that make sense to use this tool, rather than trying to do the whole subdivision or the whole project. But you could do the whole project if you wanted to. But obviously building hundreds of instructions becomes quite complex to manage. I would build the roads as one. I'd build the sidewalks or the pad areas as another, parking lots as another area, etc., and then merge the lot together at the end when I'm done. So this is kind of showing you, more and more of the kind of tools here. Let's take close this vertical design, and let's create another one. And in this case, we'll call it tank pad. And we're just going to pick these 2 lines here, tank pad. And this is a pretty complex calculation that if anybody's tried to model one of these out, you'll realize just how hard this is to do. But in this case here, I'm just going to move my designs again. Let's close this out. Tab, and let's open a 3D view again. Okay, so in here now we can say, let's take an elevation control, and let's say the pad itself, the tank, needs to be, sorry, 100, and we want it to be somewhere on the circle, doesn't matter where. So what I did is just elevate that circle to elevation 100, and then I can add a cross slope, and if I do a cross slope of, let's say, 5% for drainage into the pad, and I want to place that anywhere around here, from here to here, basically what that just did was built me a concentric pad with elevation control all the way around, where the cross slope is being held. So basically each of these sides, if I just walk it up a little bit, you can see it's like a parabolic dish now. And that, calculating that out by hand and trying to elevate all these elements to get that is an extremely complicated function. Now, if you had multiple pads, you could copy these two lines and paste them around here, change the elevation of the source line, and then have it model all of those things automatically. And get you a complex pad design for a tank farm, for example, or silos for a grain farm or whatever. So again, really simple tools, but handling relatively complex scenarios in a very easy way. Let's take an intersection. Now we're starting to build more into the real world, where we actually have a 2D layout of an intersection. This is a really simple one, 2 alignments and the edge of pavement lines with curb returns. And now we want to go through this process and give this some elevations to make a 3D model out of it. So again, let's just close out these 2 views again. Let's create a new vertical design. We'll call this one T intersection. Let's pick these lines right here. No, I'm not picking this line here. This is where I want my 2% cross slope to end and it to start the warp into the intersection here. So I put in a construction line 50 feet back from the center line or the edge of pavement here to this point here. Pick the strings that you want to make up the model. These could be strings or alignments. Let's call it T intersection. And intersection. So now we want to start the process and say we're going to start off with elevation control. Let's say we put an elevation of 100, and we're going to put that coordinate right here on the center line of this road. So that elevated the whole of that center line right here. So the next instruction I want to do is I want to link the second alignment. In this case, they're all 2D. So I want to link the second alignment to the first alignment at this point. If these were 3D alignments, then you'd want to make sure that the end point of this alignment going north is the same elevation as the alignment right here where it intersects. And then the same applies to the edge of pavement here. You want this first segment of this side alignment to have the elevation of the edge of pave here. So you design these as 3D alignments, holding the slope across the main line, and then having whatever happens further back here. Because these are 2D, I'm going to use the connector instruction, which allows me to say, from this line that's already elevated, I want to connect to this line. And what it does is it holds the elevation of the second line in a 3D view. If I just look at that in 3D a second. And let's move that over here. Let's make that. Let's find that intersection here. So as soon as I made that connector, this line, if I just undo what I just did a second, you can see it was 2D before, and now I've elevated it and made it 3D. By making that connector, it locks in this point. Now, I might also now want to say, let's add another elevation control. Let's make it 105. I've actually got an elevation back up here somewhere on this line. So let's say right here. So now you can see what I did there is now you've locked it in here and you've locked it in up here. And you've got that second line plugged in. If there was a VPI in here somewhere, so for instance, I could go in here and say, let's have a vertical PI, and let's make that PI, let's make it 99, and I want to place it somewhere, let's say back here, and elevation. So I can do that. Pick the VPI rule, and let's make elevation parabolic length, let's say 50. I want to start it somewhere back here. By doing that, what I've just done is I've put a vertical curve into this to make this sort of a smoother transition into that intersection. Again, these would be bits of information that typically you would have on the plans, or they would be part of the vertical alignment design that you're provided with. So now we've got the horizontal line and the vertical line alignments fixed. Now we can go in and start doing the edge of pavement. So we can say, let's do a cross slope construction, let's do -2%. And let's say it starts over here to here. and then from here to here. And so that's now put an elevation across this main line here. And then the next thing is this, now this edge of pavement is done, I now need to connect in these two edge of pavements here and here to lock those in. So I'm going to use connectors to do that. And again, we just say I want to connect from this point right here to this point right here. And that finds the tangent between the two. And then do the same thing over here to over here. And now that's locked those two in. And so the last thing I need to do now is put in my 2% cross slopes for the side road here. And let's say I want to do that from like here to here and from here to here. And now you've got my 2% cross slope coming down the hill into my vertical curve coming up to my intersection. Now you'll notice I also have a bust here, a little flag. And the reason for that is I never connected from this line to this line. So what I'm going to do here, this is where the sequence becomes really important, is I've added these two cross slope commands for the edge of pavement. I need to lock this one in first. So before this instruction right here, I'm just going to add in a connector. And I'm going to say connect from this edge of pave to this sideline. That fixes that bust up. Now I've got a perfect 3D intersection model, and it's all calculated, contoured, and accurately determined. And again, within a few seconds, I've gone in here and I've built out a relatively complex model in a very simple parametric way, such that if I need to go in and make an adjustment because I've got a drainage problem or something, then I could go into any one of these instructions. Let's go back up the list here, and let's pick the first cross slope here, which is that one. And let's say I want to change this to be 3%. By doing that, I just fixed the whole model, and all the other parameters were calculated off that based on this chain reaction sequence of commands that make up that intersection. So you can model one intersection at a time and have each one as a vertical design, or you could model all the intersections and all the roads all as one network in one vertical design if you want to do that. So that gives you another example of how powerful this tool is and how easy it is to make changes to the model. Again, if you go up here and say, well, maybe we don't like the way the water's draining here, I could pick on one of these vertical rules and I can move the slope start back up. And you can see as I'm doing this, I can manipulate this, and you can see that the color-coded elevation map and the contours and the slope arrows are updating automatically based on the changes that I'm making there. And that, again, shows you the sort of value engineering piece of this, is that you've got a problem with drainage, you can go back to the engineer and sit with them and make changes graphically here and show them what the effect would be, and then decide on an agreed course of action, take that final model agreed and take it to the field directly as a machine control file. Now, people ask, why is it modeling out here? Well, that's just the edge length control. So if you want to go in here and change this to 15, that will clean up the model once you're done with the modeling element. And again, if you want to see contours more accurately, you can say, I want to see contours at 0.2s, and instantly it updates the model directly here. So a tremendously powerful tool for manipulating three-dimensional line work, create three-dimensional models. At this point here, let's take a look at the last one of the rules that I haven't looked at yet. So let's just close out the vertical design. Let's close out this again. Let's create one last one here. This is an example where you might have 3 parking lot islands where you want them on a slope coming down one of these blue lines, so either coming vertically down the parking lot or maybe coming across at a slope direction in this direction. So in here we can say create a vertical design, and let's pick these lines. Now I'm going to pick all the lines apart from the 2 blue lines. Blue lines, those are just construction lines that I'm going to use to show this, and we're going to call it parking lot. And let's say apply. And here now we can start the vertical design process all over again. So we can now say, okay, let's start with an elevation rule. Let's put it at 100 again. And let's put this one up here somewhere on this line. And let's say that just comes directly across here. I may have a grade along this. So let's put a grade along this maybe. Let's say minus 3%. And I want to start that from the end here, going to the end here. And having done that, now I'm going to now say let's use a tilt. And there's 2 different ways of doing this. We could use a free slope method, and I'll do that first actually. Let's do a free slope here, and I want to do a 3% slope. I want to start it where the end of this line is to this line right here. And by doing that, what that just did is now I've got a 3% slope going this way, and I've got a 3% slope coming down here, which is going to give me some warping effect. But if I look at that in 3D, find the right model here, you can see what's happening here is it's putting a 3% cross slope down here. It's locking this one in. So this line right here is locked to that elevation right here. So this is now a horizontal island based on this elevation transfer from here to here. And then I could do another free slope from that island down to the next one. So I could say from here to here. Didn't find a target line. Let me just do that again. Okay, so now I've got a 3% free slope here. If you didn't get it quite right, you can just move that across a little bit to make it fit better. Okay, and then once you've done that one, then you can come in and say, I want to do the 3% cross slope to the next one. So you can say from this one to this one. And again, I missed it again, so snap needs to be. And by doing that, now what I've done there, if I look at 3D view, is you've got a 3% long slope between these two, but each of these pads is at a horizontal, or at least, yeah, it's at a horizontal elevation based on what elevation this was transferred through here. Now, if I did it with cross slope, I'd get a different scenario. Let's just do that just to show you how that would work. And actually, let's just take this off here because that adds a little bit of extra complication here. Let's just do the cross slope here. If I say a 3% cross slope and I start from here and end right here, what happens is this is now elevated and transferred. You've got a slope going across it, which is why you see the contours here. So a cross slope transfers the slope to this line, but it affects the slope affects the whole length of that line. So it's 3% to here, and it's 3% to here, and 3% to here, and 3% to here. So effectively, it's transferring whatever the elevations are along this line at 3% to this line, and it's now giving you a slope here. If I go in here and put that grade back in again, and say let's do a 3% grade between the end of this line here and over here, let's say. By doing that, what you've just done is you've held a 3% slope across this line, and you can see that it's changing the contours in the parking lot around here because of the 3% slope going in this direction. And again, depends on where that is here. If I put that above this command, then now what it's doing is it's got a 3% slope going in this direction, and I've said I want a 3% slope here, so this pad is sloped at 3% going in this direction as well. So again, depending on the sequence and depending on the commands that you use, would be free slope or cross slope, you'll get differing results. If I delete these two and just show you the tilt as the last one here, if I go to the tilt control basically says starting at what elevation. So I say, let's say elevation 100, and I want a 3% tilt, and I want to start it from this direction to here. What that just did was it put me a tilted plane through here, so it's holding a 3% slope, and it's doing a very similar thing to the cross slope. The only difference between the tilt and the long slope is that the tilt can be at any angle, whereas the cross slope is always perpendicular. So in here, I can move the tilt to a different direction, and that will change the result of the contours directly, because it will allow an irregular direction in terms of the tilt. So I could put 100 here and a slope down this direction, and then all these pads would be aligned directly to that sloping direction. So that's kind of the basic building blocks. Let's take a look at something more complex than this. Hopefully now you get a feel for all the commands, the fact that sequence is important, that you can nest commands together and make changes to one or more, and it will ripple its way through the whole model. Let's take a look at a more complex example here. And I'm just going to pick up another example here. Let's take Y intersection. And this one has got the road. It's also got the flow lines, the curb and gutter, and it has the has two alignments as my starting point. And so if we look at it in the plan view, you can see the line work as it's been defined by the engineer. we have the alignments from the plan and profile sheets. And so our job now is to elevate all of the line work using this parametric tool. So in here again, we're going to go create a vertical design, and we're going to pick up all these lines. We'll need them all, and we're going to call it Y intersection. And okay, apply. And just to show you that locking effect, if I pick up the lines here, you'll see that the two lines at the bottom, the house side road and how main, these are both locked because they came in as 3D alignments. So we don't want to affect those. We're going to leave those as locked. And all the other lines are 2D, so they can actually be adjusted and elevated as we start adding commands. So the first thing you're going to do here is in the plan view, you're going to elevate the edge of the pavement strength. So we're going to go in here and do a cross slope of -2. And we're going to apply that, for instance, to this line where it hits this edge of pavement. And then the same thing on this side. And what that just did now is it elevated the whole of the pavement going through the main line here. Now, all these strings to the north here, they can be elevated directly. So if I want to take, let's say, a -4% cross slope from the edge of pave to the flow line, and then let's say I want to do a cross DZ of 1/2 foot between the flow line and top face of curb or top back of curb, and then I want let's say a cross slope of +2% on the sidewalk starting from here going to here. So that's now modeled out the whole of that north side of the road geometry here. Now I got to do the south side, and to do the south side, this is where the things like connectors come in. So I need to connect in the curb returns to the main lines first, and then I can start elevating these other lines off those. So I'm going to go in here and say use a connector, and we're going to say start the connector at this point right here, and I'm going to connect it into this line right here. That now locks in this point over here and do the same thing on this side over here. So I want to connect this line right here to, it doesn't matter where you pick it, it's just telling you the two line segments that you want to join together. So that's now locked in these 2 points here. Now I can do the cross slope on the side road. So do the cross slope -2%. I'm going to come up here somewhere and apply that. So I'm going to say from here to here is a 2% cross slope. And the same thing from the main alignment here to this side line right here. And again, we can come back and move those if we want to. We don't like the way the junction is being formed. So at this point now, we've got all of the pavement elevated, and now we can start going and start doing the other elements. So we're going to go in here and say it's a cross slope, and let's say, did I say 2%? I should have said -2. So let's do -2 here. My mistake here. Do the same thing here. And you can see it's rebuilding the model each time I make a change. So this is where when you start getting 20, 30, 40 instructions going into the vertical design and saying rebuild by user is probably something you might want to do. I'm not going to do it here, but let's just take this and show you how to do that. So if you go to the Y intersection here, you've got rebuild by auto, and here you can change it by user if you want to. Okay, so I'm going to keep going here. So let's say we're going to do a cross slope of -4 now. I'm going to put a -4 between this line and this line. And then do the same thing as I get this side, because this line around here is different to this one. So I need to put another -4 from here into here. Do the same thing on the other side. So go across here and do -4 from here to here. And then the same inside this intersection. So from here to here. And that's just for the gutter pan. And then after that, I want to add in a cross DZ for the elevations to the top back of curb. So I'm going to go from here to here. Now these are one line all the way around, so you just one control should give me what I need. Because these are continuous all the way through here. If they were broken for any reason, sometimes you might break them in here, in which case you might need to go in and find that, that link across here and just put one in from here to here as well. Doesn't do any harm. And then do the same thing over here. So I'm going to come in find that half a foot elevation difference, which is from here to here. It helps if you color code these lines so you can see what you're looking at. And do the same thing on the inside of the curve here, from here to here, because I did actually break those in this one. And then lastly, I'm going to do my sidewalks at 2%. So I'm going to do a cross slope and make it 2% positive. And again, I want to take that. Doesn't really matter where you do it, so I'm going to do it from here to here. And you can also put in things like curb drops for ramps and for things like driveways with this. So you can do those as long slopes and grade changes as you go through the intersection along the line, like we showed you in the very first exercise we looked at. And you can see here very quickly, I'm building this and it's interactive. I'm seeing the model appear as I go, and I can see the results almost instantaneously in terms of the slope arrows and the contours and the color-coded elevations of the drawing. So now I can see, if I look at my drainage patterns, I can see my drainage is coming through here. It's draining into the intersection. The water drainage is draining to this crown line and then out here. And it all looks pretty good right now. The contours look nice and smooth. If I go into the 3D view, however, you might find that, for instance, when you look into these areas, you might not like this sort of break that's going on right here because of the way the slopes work. This has got quite a steep slope going across the intersection, and this one's coming in relatively steeply, and as a result, you may decide that you don't quite like this, so you might want to interpret the slope across here and then put another cross slope in here to kind of bring this curb line up more gradually so it intersects. But again, you can add commands and instructions in here to change elevations along this curve to get it to do what you want. And every intersection is different, and so you need to kind of analyze what's going on around the intersection and add additional instructions should you need to do that at the right location in the sequence here. So typically do it on your pavements. Once you get the pavement elements done, I would get those right first before starting to add all the other elements. But you can always come back in, click on an instruction and say insert the next one above this, and it will put it in the right location in the list for you, or you can drag and drop them in the list if you need to. But again, relatively simple process to build out relatively complex three-dimensional models. This model is now ready to go to machines. You can just save it out like any other surface and send it out to the machines. If you go in here, you can turn off the line markings. You can turn off the, turn on the line markings. You can also show the rules or not show the rules. So now you've got a 3D model that's parametrically constrained that is ready for machine control. And you can start doing your subgrade adjustments if you need to by just dropping subgrades in on this surface like you would do normally, or by doing things like offset lines, offset slopes. And in 5.2, there's some really nice string modeling tools to do some offsets using pairs of strings, and you can extend the slopes or calculate intersections of two pairs of strings and things like that. So some additional tools in here, along with side slope and corridors, to build out relatively complex three-dimensional site subdivision type models. Okay, so at that point, DeLondon, I'm going to pause here and stop, come up for air a little bit. Bit of a whirlwind tour here, but let's open up for questions and we'll try and answer those. But Nick, have you got any comments before we do that?
No, you actually showed the example that I had as well too, right there. So that was really good. We do have a couple of questions here that I haven't been able to answer yet, and hopefully you can show them.
Okay.
Number one, can you show an example of how to tie in utility networks such as storm inlets as low points in the road to ensure drainage?
Yeah, so if you know where there's a storm inlet in here, then you would just add an elevation control for the inlet. So for instance, you know, again, not knowing the elevation, but we could just go into the vertical design here, edit this. And what I would do is go into the early stages here where I started to add elevations in here. So let's pick a location here. So I've got the connectors to elevate the curb, then I've got the cross slopes. So it's going to come in after the cross slopes of the pavement here. So it's going to come in here somewhere. So what I would do in here, if I say, okay, I need to add an elevation control, and I'm going to guess an elevation here, or I could say doing a long line snap. So I could just say pick this line just to get an elevation roughly in this location. Let's say pick here. So I just pulled out an elevation, but let's say maybe we want to drop it a little bit. So 98.5, just to make it obvious. and we're going to say it's going to be at that location. And so now what that's doing now is it's dropping the curb inlet at that point. You saw it all drop, but because this dropped, 4% dropped, the half a foot dropped, and the 2% cross slope dropped. So everything moved in association with that location. So that's how you would add in either fixed elevation controls that you were given on any feature, or you would use it for putting in elevations of things like drainage locations. And depending on where you place it in the list, this is the key, is you should probably do that when you're doing the pavement before you waste time doing all the sidewalks and the curb and gutter sections. And make sure you get all the drainage and everything right for the pavement before you start adding all the other elements in. Okay, does that answer the question?
Yep, perfectly. And then the last question that we have before we wrap up, within the vertical design tool, is there a way to apply subgrade and oversizing to roads, or do you have to use tools outside of the vertical design tool to do all that?
So currently vertical design only applies to one surface. You could use it for modeling subgrades if you wanted to. So for instance, you could take a copy of the vertical alignments and drop them by the depth of the material and then start elevating the edge of pavements and stuff in the same way, but for subgrade. Or you could take the strings that were created from here and then use the offset tools, the two new offset tools that we have for creating offset surfaces, or you could use things like side slope. Or if there's simple subgrade adjustments, you can just use the subgrade adjustment and drop those in on the surfaces here. So subgrade is something we know we need to work on and build out more tools for, and that will come over time now. But currently the tool is designed for single surface at a time, and you have to use the other tools to do your subgrades as it is right now.
Perfect. And then this tool is available in the site modeling license of Business Center, that's correct?
That's correct, yep.
Okay, perfect. That looks like that's all the questions we have today. Thank you very much for taking the time, Alan. Is there any other questions anybody wants to throw up on the board, or are we good to go?
If you have any feedback or additional questions, please feel free to email them to either myself or Nick, alan_sharp@trimble.com, or Nick, I guess it's Nicholas Fifarek. It's a rather grand name, Nicholas Fifarek at trimble.com. Or you can post your questions on the forum because this is a public presentation. The word is out on 5.2. We also showed it at the Power User Group a couple of weeks ago. So it's common knowledge now, so you can ask questions about this on the forum as of today, and we'll try to get your questions answered. This video will be posted shortly on the website, I guess, to London, so we'll have it available for you, hopefully by the end of the day. And I guess we should put links on the forum to it as well, so everybody can go find that on the Trimble website as and when it's posted. Okay.
Perfect. Do we have an exact release date on 5.2 yet?
I don't know if it's exact, but the last I heard was next week. So originally the survey guys asked us to push it back to the 18th of November because of some changes they were making to something. That's coming up next week now. So I believe it's next week. And the announcement Anne-Marie said was going out today, I think. So, or this week at least. Anne-Marie, I can't remember what day you said. But it's we're in the rundown to the release now. We've been debugging it and getting it ready. It's pretty good now. Stability wise is really strong, and I think we're ready to roll with this thing. And this is version 1 of the vertical design. We're continuing to develop more tools in this for more instruction types and also more sophistication in some of the things it does. And the subgrade is certainly on my list of things to look at as to how we could use this tool for doing full subgrade modeling as well as finished grade modeling. Okay. But the slope, the two new tools, I would stress that if you're trying to do subgrade modeling, the two new tools that have been added as macros you can get from the TML. If you use TML status today, then use TML status to grab the two new tools, but they're called slope, intersect, and offset slope. This one basically allows you to pick two pairs of lines. So for instance, you might have center line and edge of pave, and then you might have hinge line and bottom of slope, and you want to calculate the intersect of two offset surfaces. So they can be offset vertically or perpendicularly now, and that will calculate you where the subgrade meets the offset of the side slope. So you can find like a topsoil strip on the embankment and a 2-foot offset for the center line to edge of pave. and it will calculate you the intersection strings and all the offset strings, so you can build a subgrade surface really fast. The second instruction one here is offset slope, and that allows you to take a center line and a slope or center line in the second string, or two strings, to calculate the cross slope, and then you can project it out at a distance. So you can say, I want to offset by 10 feet or 5 feet to project out a surface. And so if the surface is super elevating between, let's say, -2 and +4 or something like that, then the projected offset point will also be super elevated by the same cross slope at the offset. And then you can apply a vertical or perpendicular offset to that to calculate at an offset downwards. So if you're trying to calculate for, let's say, offset strings behind a back of curb at the cross slope of the pavement, these two tools will be a godsend for you in the product. And those are available from the TML status command. If you don't know anything about that, then download TML status from rockpilesolutions.com, and that will give you this tool. And then you can basically use this tool to manage your TMLs or macros for Business Center, and that includes all of the Trimble macros as well as all of the Rockpile Solutions TMLs. And then you can keep them up to date and see what's available very quickly through this command. So again, I'd recommend you get this, go to rockpilesolutions.com, download it, and then when you install it, just by running the exe, and then when you've done that, when you run it inside Business Center, it will check all the TMLs that you've got installed against all those that are available, and give you an ability to download and install the ones you don't have, and also update any that may be out of date. And they're changing quite frequently, so I'd recommend you get that tool. It's an awesome tool for managing your TMLs. Okay, well, again, thanks a lot for organizing this, Nick and London, and hopefully you guys will get some good value out of this vertical design tool when it releases next week. And again, thanks for taking the time out of your day to come to the meeting this morning. Appreciate it.
Thank you very much, Alan. Just for everybody, we are going to have another Power Hour. It's going to be on December 11th, same time. We're going to be going over the second thing that we're releasing on the construction side with this latest 5.2 release. It has to do with importing in data via CAD cross sections. So do sign up, do get registered, and we look forward to seeing you. Thank you very much.
CAD and PDF cross sections, Nick.
Yeah, CAD and PDFs cross sections. Thank you very much, all.
Thank you all. All right,
Thank you, everyone.
Okay, bye-bye.